Okay, in this video I want to expand a little bit on how to use these VTK files in Python. For example, here we have a file torso.vtk, and as you can see in this example code, it has to be opened using a VTK structured points reader. But how do you know what kind of reader to use for this type of file? That's what I want to go into. Well, here I opened the file torso.vtk, and as you can see, it starts with a bit of readable text and then a big part of unreadable data, which is clearly binary data. But the file always begins with a readable text, and there is a document which is also on SharePoint. You can find it there, fileformats.pdf, that explains the format of these files. So if we compare this, here on the left you can see that the first part of the file is the version identifier, well, data file version 3.0. The second part is the header, untitled here. The header is not important, it's just some piece of text that describes the file, but it's not used in any way by the system. The next part is file format. That describes whether it is ASCII or binary. There are only two options, ASCII or binary. In this case, for the torso file, we have binary data. That's why from line 11 on, it's not readable anymore, because that's binary data. The beginning is always text, but after a certain moment, we have only unreadable binary data, as is specified here on this line. And then the most important part, the fourth part, that describes the structure of this file, the structure of the data set in this file. And in this case, it's of the type structured points. What that means, I will go into that in a minute, but here you can see that the kind of data in this file is structured points, and that is the reason that in order to open it, we have to use a structured points reader. So in general, when you have a VTK file and you don't know how to open it in an editor like Notepad++ here, and check what kind of data set this is, and that defines what kind of reader you use to open it. Well, let me explain what kind of data sets we have. For that I will go to another document which I think describes it a bit clearer. If you look in VTK, you have, as we can see here, we have three types of data sets. We have polygonal data sets. This is much like the objects in Vizard, for example, which exists out of polygons. A polygon being a small square or a triangle. Such data can also be in a VTK file. That looks like a model in Vizard. It's usually not a volume, but it's something empty. Then we have a structured data set. That's also something we use a lot in VTK. That's specifically for the volumes. And we have the unstructured data sets. We will not go into that. What you should remember is that when we go into the structured data sets, that it's a collection of points in 3D space. Like I said, for the volume, in the volume you have voxels, which are the measured values in the volume, measured by some kind of machine, MRI scanner or whatever. But these points also have values. So for each point in the volume, it has like a scalar value or a color value or a vector value. The difference is that a scalar means there's only one value in the point. Color means there are four values: red, green, blue, and alpha. And a vector means that there are three values for that point, x, y, and z. So here these fields are described. So a scalar is only a value, a double. A color is red, green, blue and alpha value, so 4 values. And the vector is an x, y or a z. So that's about to make the distinction that you have the points, and each point in a volume has certain coordinates that defines where it is, and each point also has one or more of these fields. So for each point we can define a scalar or a vector or a color or combinations. Then the data set, so we have a so-called structured data set or a polygonal data set. That's what we will use most of the time, one of these two. Polygonal means it's like any object that you have in Unity or in Vizard. It consists out of polygons. It's usually empty inside. It only has a skin, a surface. But the structured data set, that's more interesting, more new for us. And in these structured data sets, there we can have basically two different kinds. We have the structured points and we have the structured grid. And you see the difference here. If you have a structured points data set, it's a very regular grid of 2 or 3 dimensions. To keep it simple here, we have an example of 2, but it can be extended to 3 dimensions, that you have a cube. This is what we call structured points. It's very regular, so all these points have the same distance in horizontal and in vertical direction. So that means that actually if you define the origin of this cube, and you define this distance, and you define how many points we have in each direction, for x and y and z, then you have completely defined this structure. You don't have to specify the coordinates of each point independently, because if you know the origin, if you know this distance, and you know how many there are in each of the 3 directions, then it's completely defined where these points are. So that's quite efficient. So you don't have to specify the positions of all the points, which would mean a lot of x, y and z coordinates, but you only specify origin, distance and dimensions. A structured grid is something different. It's also something that's very regular, as you can see. It has a kind of regular structure, but it's not necessarily a cube. It can have a different shape. Here is some kind of rounded shape. But still it's regular, meaning that it has some kind of columns and rows and a regular array of points. But in this case you have to define the position of each point. Although it is regular, you do have to define the position of each point, otherwise you don't know where it is. It's not a regular shape like this, but yeah, it can have all kinds of curves. So a structured grid is usually not a cube, but it has some other kind of shape. Back to our torso here, torso.vtk. This, as I mentioned, is a structured points data set. So it's like this. You only have to define the origin. You have to define the spacing. Well, actually, that can be different in the x and the y and the z dimension, but in this case, it's 1 in all directions. And you have the dimensions. So that means we have 128 points in that direction, 128 in that direction, and 147 in the z direction. This completely defines where the points are. Then still we have to give the values for each of these points. So we had some machine measuring values for us in each point. So we still have to give the values in each of these points. And that is in the binary part. So this whole part, unreadable binary data, that contains the values of all these points. So the value for this one, and that one, and that one, and that one, and then the next row, and so on. In total, that's 2,408,448 points, which is actually the multiplication of 128 times 128 times 147. So it's redundant data. If you know the dimensions, you know the point data, but okay, they still mention that. And each point is represented by one unsigned character of 1 byte. So that means in order to store the data for these 2.5 million points, you need 2.5 million bytes, because each point is stored in 1 byte. If you would count the length of this file, it would be 2,408,448 bytes plus all the bytes needed to store this text. So we have this text here, which is stored, plus this number of bytes, and that's the total length of the file. Okay, maybe that kind of information is not really relevant for you, but it is important to understand that this is structured point, so it will look like a cube. When you open it, it will look like a cube, and we can see that if I run this program. It's appearing here. Now you see it looks like a cube, because it's a structured points data set. It's always a cube, or at least a block. The dimensions in all the directions don't have to be the same, but it's always a cube-like structure. Different from, for example, density file. It's another VTK file. This is a structured grid. So if you open this volume, you will see doesn't look like a cube, but it has a different shape. If we look at this one, this contains ASCII information, not binary, which means that we can read all these values. They are simply in text. It has these dimensions. It has so many points, which is again the multiplication of these values. Each point is a float. In this case, we first have to define all the points. So this file is much longer, and the definition, I don't know exactly where it ends, but somewhere if you scroll down, here, until here, here and above, all the points are defined. So what are the coordinates of this point and that point and that point and that point and so on. And then after that, we have the values in these points, which are scalars. Again, the same number of values, but now, as I said, the file is much longer because we first have to define the points, and then we can define the values in the points. And here, for example, the Honolulu.vtk, it's also a VTK file, also ASCII, so readable, but this is poly data. This is polygonal data. This defines an object which is not really a volume because it's empty inside. It's only the outside of the object is described using polygons. So for this one, to open this one, you would use Polydata Reader. So yeah, my point is, if you want to know what kind of reader you need, just look at the data set. This is again structured points, Polydata, and so on. You can simply open the file with a text editor and read it. To understand what's inside, keep in mind that we have basically three main different categories. The structured points, which is a cube-like structure. A structured grid, which Yeah, it's also a volume, but not a cube shape, but another shape. And we have the polydata, which is like an empty object. Okay, I hope this helps you a little bit to understand the formats of the VTK files and to know how to open them in your program.